This conference would not be possible without our sponsor support. And we really appreciate their participation in the conference. They have been super careful. In addition, these are really interesting talks, technological talks. So I believe people will learn a lot. I'm trying to get the schedule in front of me. Alan, I use our sponsor speaker right now, I guess.
I am indeed.
Okay, we have Alan Benjamin from GigaIO giving a talk, I believe, about GIO technologies.
Exactly correct. Thank you so much. Wow, what a great talk from Pavan. It's a great lead in to what we're going to talk about. I'm going to give people a brief introduction to GigaIO. We've given technical papers on different aspects of our network in the past, and we will do so again in the future. But just a quick overview for some of the project work that we are doing. So let me bring my screen up and make it full screen. Okay. So I'm going to give a brief overview of some of our products, including a new product that may surprise some people in terms of form factor. And we take our technology, which I'll talk about in a second, we serve it up in the form of what we call impossible servers, really optimizing on great performance, very simple to scale, and very easy to deploy and manage. And we've worked all parts of the hardware and software stack so that in large measure, these are you literally roll them in, plug them in, and get going. Our core technology is what we call our Fabrics memory fabric. As I said, we've presented different aspects of this here at Hot Interconnects in the past, and we will do so again. We sit above the switch layer, the switch chips themselves. It starts with us with device and box control and gathering full telemetry data upon everything that happens within our racks and our networks. We build up to the data planes, which for us now we traditionally have been based upon PCI Express, and it's still a mainstay for us. We also now fully integrate with Infinity Link and with NVLink, and we can deal with GPUs that are in those formats and help to arrange those. And in the very near future, we will have CXL and large amounts of memory capability. This is all controlled by our control plane, our fabric manager, and our host services that run on individual servers. And we serve up all the control through our Redfish APIs and our CLIs, which then interface into the tool sets that most all the data centers already use, whether it's the DevOps chains and they have Ansible scripts, and or the user, let's say user level job schedulers and cluster managers, things like Base Command Manager, which is part of NVIDIA AI Enterprise, or Slurm, or PBS Pro, or other sorts of schedulers. We integrate, and we can actually allow people to use multiple tool sets, and it doesn't matter. They don't have to know or manage what's happening in the data planes. So with Fabrics, we achieve two things. We can scale up a given server, and we'll talk about that here in a second, but we can scale up resources on a given server to quite large numbers. And when I say quite large numbers, it can be 32 or 64, or in some instances, even beyond that, depending upon the GPU. That matters. We can scale up the resources on a node. We can do the same with storage. We can also scale out, so we can create arrays of our supernodes. There is limitations, as Pavan would say before, these huge data sets are different, but we scale out to today about 12 supernodes, so to about 400 GPUs. So we look at artificial intelligence, and it's a key marketplace for us. Pavan did a great job of talking about these large foundational training jobs, which is a classic scale out infrastructure. And this is really not where we are focused. So he talked about Ethernet and InfiniBand as the foundation of being able to do foundational training. We, on the other hand, are really focused on the inferencing side, which is really more of a scale up problem, right? He talked about being able to use tens of GPUs, which in fact is very close now. You need to hold this model in memory. Mark Basiak yesterday, who talked about their AI models, the mid range for him now is about 2 terabytes, and so we're now in the 10 to 20 GPUs that become important, and in the fine tuning and augmentation arena. Again, about 32 to 100 GPUs. So that's really our sweet spot, and that's where we are focused. The problem here, if you're going to go beyond 8 GPUs, so both NVIDIA and AMD, they have boards that have 8 GPUs connected with NVLink or Infinity Link that do a really nice job, high bandwidth, good performance. But when you go from GPU number 8 to GPU number 9, there is a tremendous drop off of performance. So this is data that came from NVIDIA. And you can see when you go from 8 to 9, you can be assured this is an optimized InfiniBand connection, and they're showing a 40% drop between GPU 8 and GPU 9. This was why they brought it out as part of the announcement around the external version NV switch, and for all obvious reasons. So Fabrics solves this same problem. So here's some data that comes from one of our customers. They were doing training on a smaller Llama set, 8 GPUs in a server, right? It was taking them 19 minutes. They combined 2 servers now running across Ethernet. 19 minutes goes to 15 minutes, 32 GPUs, 15 went to 10. And when they ran the same model across our Fabrics network, then 8, of course, was still 8 because we use the same construct, but 16, you can see the scale factor now is really quite good. 19 minutes became 10 minutes, 10 minutes became 5 minutes. And so as you scale up on our system, the performance levels are considerable. One of the things that we set out to do was make this super easy for people to be able to actually use it. So on one hand, everything shows up in the LSPCI, so it's all available there at the operating system. You add 32 GPUs, all 32 of those GPUs are there. But it turns out that's necessary but insufficient. You also have to integrate in with the graphics drivers, and we carry it all the way through the PyTorch and TensorFlow library level. And there was considerable amount of software at each level working together with NVIDIA and AMD to make this possible. So that today you can take optimized containers from NVIDIA or optimized containers from AMD, and you can simply drop them onto a supernode. You don't change a single line of code, and you now have 32 GPUs, and it will run 4 times faster than if you had 8 GPUs. Now, for something in a fun sort of way, that fabric, right? So we take the fabric; it is the heart of our supernode, and we can apply it to other formats. So we had one of our national security customers that came to us and said, "Look, the philosophy of what you do in a supernode of enabling us to increase resources, change resources, move the topologies and configurations of what's happening within this rack or multiple racks is really important to us. We have a dire need now for meaningful computation that can take place out on the very edge. And we'd love to have effectively a supernode in a box that we can carry on board a commercial airplane." And I'll show you the result of that. So the supernode itself the world's first 32 GPU server. It is one, in this case, we can attach to one server. If people want more than one server, we can add additional servers into this rack. Of course, it can, depending upon the amount of power that is available in the environment, we have many customers that split this across 2 racks or 3 racks, so it's entirely splittable. It is a single version of the operating system, and if you're paying for software by the node, it is a single node. And there's whatever software that, if it has not been distributed, this is quite simply the way that they can increase their compute capacity. So here's what we call GRIF. So it is a modular system, wheels, handle, it literally can go anywhere. The individual sleds themselves are full Genoa-based servers. They can be up to 500 terabytes of storage, and as the storage guys, we're now hearing about storage options that in the very near future will make a individual sled here up to a petabyte. We can add accelerators of all kinds. So we can add anything, an H100 all the way down to video capture cards, or things, almost anything, FPGAs, almost anything that'll plug into a standard PCI slot. And we even have 100 gig Ethernet switch available as a sled. Any of those sleds can go in any of those slots, and you can make configurations in a variety of ways. And then we've designed this so that we can connect up to 5 of these GRIFs together, and you can get 30 slots. So an example here, you could have a 2-server configuration with 256 cores. You could have 16 high-end GPUs. You could have 4 video capture cards, an Ethernet switch, and 3.5 petabytes of data, all in a platform that when you get done with it, you can literally pull up the handle and roll it away. So in summary, right, what we enable people to do across both of our platforms, both GRIF and Supernode, is to deploy and scale all GPUs, whether they're NVIDIA, whether they're AMD, whether they're Intel, or other companies. We get great performance. We achieve just about linear scale. They are fully engineered so that they are simple to set up and administer. The software tools are there, the hardware tools are there, and we integrate with your management tools. And we are open and standards based. We work with a variety of GPUs, like I said up front, but also inferencing cards, video cards, FPGAs, and darn near anything that'll fit into a PCI slot. So if you'd like to learn more, there's my email address. We'd love to talk to you. And thank you for the time, Pasha.
Thank you very much, Alan, for presenting very interesting technology. There are some questions in the chat. I will read out one, or I don't know if you can read.
I could probably get there eventually, but if there's one or two I can answer quickly, sure.
Yes, I will read out. What fraction of Supernode is GRIF?
I'm sorry, say that again?
What fraction of a Supernode is GRIF?
Is GRIF?
Yeah.
So, a Supernode, for example, will handle up to 32 or 64 GPUs. If you take GRIF, you noticed on the design, there's some grooves on both sides. So it's designed to be laid down, and you can stack up to 5. You can almost create a Supernode out of 5 GRIFs. So a GRIF is, for all intents and purposes, about 1/5 of a Supernode.
Okay. Slide 7 gives an example of training, but in the early slide, you do not focus on training. How suitable fabrics for AI training?
Well, I think Pavan did a very nice job of talking about, depends upon the scale of training you're doing. All right. So, if you're doing training like Llama 3 or Chat GPT and you're going to use tens of thousands of GPUs, Fabrics is really not the network for you to do that. If you're talking about augmentation training, or if you're doing a fine tuning training to one of those models and you need 32 GPUs, Fabrics is great. Supernode is great.
Okay, thank you.
Excellent.
Thank you again, Alan, for very interesting presentation and talk.